Today we will discuss two special characteristics of the exponential growth. One is doubling time and the second one is half-life. And doubling time can be denoted as capital T, small d in suffix, or small t and small d in suffix. So when a quantity that is growing at a fixed exponential rate small r turns out to be double in size or number after a fixed amount of time, regardless of the starting point, then the time, that is fixed amount of time, is called doubling time. That is, it takes the same amount of time to grow from n0 to 2 into n0 as it grows from 2 into n0 to 4n0 and so on. So we know the formula of exponential equation, that is n equals to n0 e to the power rt, and so the doubling time can be found by setting n is equals to 2 into n0 at time is equals to tt. অর্থাৎ ডাবলিং টাইমের পরে যে ইনিশিয়াল অ্যামাউন্টটার ফাইনাল অ্যামাউন্টটা ইনিশিয়াল অ্যামাউন্টের ডাবল হয়ে গেল। তো আমরা যদি এই ভ্যালুগুলোকে এই ইকুয়েশনে পুট করি, দেন উইল গেট in 2n0 is equal to n0 rt. So we put the final amount n here in 2 into n0. Now we cancelling n0 from the both sides, then it will appear 2 into 2 is equal to e to the power rt. So here you can see that the length of time required to double the quantity does not depend on the starting quantity. So এই ইকুয়েশন থেকে দেখা যাচ্ছে যে স্টার্টিং কোয়ান্টিটিতে কি ছিল তার কোনো রোল নেই, কারণ এটা ক্যান্সেল অফ হয়ে যাচ্ছে আগের ইকুয়েশন থেকে। So now we taking natural log of both side gives ln2 is equal to rtd, এবং সেখান থেকে আমরা বের করতে পারবো যে ডাবলিং টাইম td is equal to ln by r. ln হচ্ছে গিয়ে ন্যাচারাল লগ, দ্যাট ইজ লগ e to the base e. তো ln2 এর ভ্যালু হচ্ছে 0.693. সো এটা ফ্র্যাকশনে আছে। So the growth rate r is expressed as a percent instead of a fraction. Then we get আমরা যদি এই ফ্র্যাকশনটাকে আমরা পার্সেন্টে নিয়ে যাই তাহলে 100 দিয়ে ইনটু এসে যাবে উপরে, দ্যাট ইজ 69.3, that is near about 70. So from this equation we can find that a bank give you 7% interest, then it will take 10 years to double what you have in your account. তো এই ইকুয়েশন থেকে আমরা সেটা বুঝতে পারি যে যদি আমাদের 7% ইন্টারেস্ট দেয়, দ্যাট ইজ r ইকুয়ালস টু 7% হয়, তাহলে আমাদের টাইম লাগবে যে কোনো অ্যামাউন্ট আমাদের সেভিংস ব্যাংক বা ফিক্সড ডিপোজিটে থাকলে সেটা 10 ইয়ার্স বাদে ইনিশিয়াল অ্যামাউন্টের ডবল হয়ে যাবে ফাইনাল অ্যামাউন্ট। এবার যদি আমরা একটু গ্রাফিক্যাল প্রেজেন্টেশন এটা দেখার চেষ্টা করি, তাহলে আমরা দেখব যে এখানে ইনিশিয়াল অ্যামাউন্ট ওয়াজ n0. সো ইট টেকস when it becomes 2n, what is doubled, it takes this much amount of time, and from 2n to 4n, that is 2 times of 2n, the amount of time is here also the same as the first doubling. And if in the second and the third doubling 4n moves to 8n, but the time required to doubling is as same as the previous one. Now we solve a problem here. So here there is a problem where it says that it took about 300 years for the world's population to increase from 0.5 billion to 4 billion. It will assume exponential growth at a constant rate over that period of time. What would that growth rate be? So এখানে বলে দিয়েছে আমাদের initial population was 0.5 billion and the final population was 4 billion, and it takes 300 years to increase from here to there. So we have to identify the growth rate. So using the formula, that is n is equal to n0 e to the power rt. So we know here the n is 4 billion and n0 is equals to 5 billion, 0.5 billion, and t time t is equals to 100 is 300. So we have to identify the r. So by putting this value and we taking the natural log of both sides, we'll find that the r is 0.00693, or if we converted this fraction into percentage, then that is 0.693%. But here we have solved this problem by using formula and calculator. But if I use this with the doubling time rule, then you can find that 0.5 billion to 4 billion there is population grow from 0.5 billion to 1 billion, that is one doubling, 1 billion to 2 billion, that is second doubling, and 2 billion to 4 billion, that is third doubling. So it takes 300 years for 3 doubling. So for one doubling it takes 100 years. So by putting this formula that we have, that is 69.3 by r square. So if we put td is equals to 100, then percent r, or the fraction is 0.7%. If we take this, then it is 0.693%. that is as same as the previous. So we can use this formula also for solving this problem. Now we go to the half-life. Half-life is denoted as t under suffix half, or small t under suffix 1/2. So when the rate of decrease of a quantity is proportional to the amount present, exponential growth becomes exponential decay. For an exponential decay, a reaction rate coefficient k plays the same role that r played for exponential growth. So here rate decrease with time, and that's why we slightly change the growth rate r to k. So the formula, the exponential decay can be expressed as the as same is that n is equal to n0 e to the power rt. Here r is replaced with k and the minus sign is used as it is exponential decay, or the quantity will be decreased at a proportional rate with the time. So here k is the coefficient, rate coefficient, n0 is the initial amount, and n is the amount at time t. So here we relate half-life to this to reaction rate. Then we said n is equal to n0 by half at time t is equal to t half. That means after some time from 0 to t half, the initial number becomes half. That is, the final number n would be n0 by 2. So the formula looks like we replace n with n0 by 2 and the rest of thing is same. So here also we cancelling off n0 in both sides, we will find half is equal to e to the power minus k t half. So you can see that the length of time required to half the quantity does not depend on the, here also on the starting quantity. So by taking natural log of both sides gives n ln half is equal to minus k half. So we will find t half is equal to ln 2 by t, that is 0.693 by k. So now we are going to represent this in in a graphical format. So you can see here that if the initial amount is n0 at time 0, and after spanning of some time, that is t half, it becomes n0 by 2. So the initial amount will reduce to half of it after some time t by half, and then it becomes again half, that is n0 by 4 after spending the same amount time, that is t half. So likewise we will calculate this the exponential decay. Now we are going to solve a problem here. So the problem is bismuth 1-210 has a half-life of 4.85 days. If we start with 10 gram of it, now how much would you have left in 7 days? So here we have to identify first the k, because we know the half-life here. So by putting this formula as t is equals to 4.85 days, then k will be is equal to 0.143 days. So now we know about everything about in this formula, that is n is, we have to identify n. So n0 is 10 gram, k is equals to 0.143 days, and t is equal to, we have is 7 days here, because we have to calculate the amount left from the initial amount after 7 days. So by putting this value, we'll get 3.68 gram. So after 7 days, bismuth 210 will be 3.68 gram from the initial amount of 10 gram. Thank you for watching this video.